In the summer, you must have seen certain advertisements of sunscreen lotions. Now, in these ads, they say that you must use these sunscreen lotions and creams to protect yourself against the sun's UV rays or ultraviolet rays. Now, we know that the sun is a source of light, and we know that it provides us light rays. Now, what are these UV rays? Do you think that the sun provides us with more than just light rays? Do you think that the sun emits different kind of rays? Let us find out. The sun indeed does emit different types of rays. But we human beings, our eyes are not able to perceive all types of rays. Just like we are not able to perceive all types of sound, similarly, we are not able to perceive all types of rays. So let us find out what kind of rays the sun emits. Light is an electromagnetic wave, and we know that a wave has a wavelength and a frequency. So what can we say? That light has a wavelength and a frequency. Now look at this animation closely. Here you will find that a man in his boat is being rocked by the waves in the sea. Now you will notice that the length of these waves or the wavelength is quite large, and as a result lesser number of waves are hitting the boat, due to which the boat is rocking up and down very gently. This is because the frequency of the waves is less, or in other words, the number of waves hitting the boat is less. So what can we say? We can say when the wavelength is more, the frequency is less. Now consider another animation. In this animation you will find that a man in his boat is being rocked by the waves violently. If you observe closely, you will see that the wavelength of these waves is smaller, and as a result the number of waves that are hitting the boat per second is more, or in other words, the frequency of the waves is more, and as a result the boat is being rocked violently up and down. So we find that when wavelength is increasing, the frequency is decreasing, and similarly when the wavelength is decreasing, the frequency is increasing. So now let us find out about the different kinds of rays the sun emits. Here you find what is known as the complete electromagnetic spectrum. This gives a listing of the different kinds of rays emitted by the sun. They are the gamma rays, the X-rays, the UV or the ultraviolet rays, visible light that we are able to see, infrared rays, microwaves and radio waves. Now if you observe closely, the wavelength of these rays increases in going from gamma to radio waves. Likewise, the frequency increases going from radio to gamma waves. So what can we say? That gamma rays have the highest frequency and the lowest wavelength, and radio waves have the highest wavelength and lowest frequency. Now observe this part. Here we have listed the visible light spectrum, that is the part of the spectrum that we are able to see. Do you know how we are able to see? Our eyes have special cells in them known as rod cells and cone cells. These cells are responsible for the vision sense in us. Rods are cells that help us in dark, and cones are cells which help us to see light and distinguish the various colors. So what are the different colors that are present in the visible region? They are starting from violet and ending at red. Now as you can see, the wavelength of the waves is increasing on going from violet to red. The wavelength starts at 400 nanometers and ends at 750 nanometers for the visible region. So we can say that the wavelength of red light is greatest and the wavelength of violet light is least in the visible region. So the wavelength of red is greater than wavelength of violet. And what does this imply? This implies that frequency of red is lesser than frequency of violet, and the frequency decreases on going from violet to red. Likewise, the wavelength increases in going from violet to red. Now we talked about the visible part of spectrum, that was light. Now the other rays that are emitted by the sun in the spectrum are not visible to us. We cannot perceive them. So what are those things called? That part of the spectrum that which we cannot see is known as the invisible part of the spectrum, and that includes gamma rays, X-rays, UV or ultraviolet rays, infrared radiation, microwaves and radio waves. Now we shall talk about the different rays individually. Here we have considered the ultraviolet part of the spectrum. The ultraviolet rays have wavelength from 10 nanometers to 400 nanometers. It undergoes reflection, refraction, scattering just like visible light rays do. It travels in a straight line with a speed of 3 into 10 to the power 8 meters per second, and they also cause health hazards like skin cancer. And it is due to this that doctors and therapists advise you to use skin lotion and sunscreen during summer. But ultraviolet rays have certain utilities as well. Now we know that the natural source for vitamin D, as far as food is concerned, is found in cheese, margarine, butter, fortified milk, and various other food items. But did you know that our body is able to manufacture vitamin D in a particular way? That way is through ultraviolet rays that come from the sun. So when the body is exposed to ultraviolet rays, it can manufacture vitamin D, which is essential for the bones in the body. So ultraviolet ray is not all bad. Minimum exposure to ultraviolet ray is actually necessary for the body to manufacture vitamin D. Now let us talk about the infrared part of the spectrum. The infrared spectrum ranges from 700 nanometers to 1 millimeter in wavelength. It undergoes reflection, refraction and scattering just like visible light does. It also travels in a straight line with a speed of 3 into 10 to the power 8 meters per second, and it is less scattered. Why? Because they have longer wavelengths. Now infrared radiations also have certain uses. What are they? They are used for therapeutic purposes by doctors. It is often used to cure pain in therapy. It is used in photography at night and also in mist and fog. Why? Because as I mentioned, they are less scattered. It is also used in television remote control and other gadgets like heat sensing devices. Now we talk about gamma rays. Now gamma rays have the shortest wavelength. That is, they are less than 0.01 nanometers. They have the highest frequency. They can easily penetrate through the human body and damage our body. And as a result, gamma rays are very harmful. Now you will be interested to learn that the atmosphere of the earth blocks out most or all of the gamma rays coming in from the sun. Gamma rays also travel in a straight line at a speed of 3 into 10 to the power 8 meters per second. And gamma rays are again not always bad. They are used in radiotherapy to kill cancer cells. Now we talk about X-rays. X-rays have a wavelength that ranges from 0.01 nanometers to 10 nanometers. Now as you know, X-rays are used for detection of fracture in bones. If you have got hurt in some place in your body, the doctor uses X-rays to determine whether there is any bone fracture or not. X-rays are also used in scientific studies of atomic arrangements in crystals and complex molecules. And X-rays also travel in a straight line with a speed of 3 into 10 to the power 8 meters per second. Now we talk about microwaves. Microwaves have wavelengths that are quite large, that is from 1 millimeters to almost 1 meter. Now they are used mostly for satellite communication, and you will be interested to learn that they are also used for cooking in microwaves. You must be having a microwave at your home, right? Which your mother uses to cook. That microwave machine uses microwaves for cooking. And microwaves also travel in a straight line at a speed of 3 into 10 to the power 8 meters per second. Now, as I mentioned previously, the microwaves that are available in the market and which you probably have at home uses microwaves for cooking. The microwave part of the spectrum is responsible for cooking food that is kept in the microwave oven. And lastly, we talk about radio waves. Radio waves have the longest wavelength, that is above 10 meters. These waves are mainly used in radar communication and also in radio and television communication because these involve long distances, and radio waves, due to their longest wavelength, are less scattered. And radio waves also travel in a straight line with a speed of 3 into 10 to the power 8 meters per second.